Good day, my dear students. How are you doing today? It's Mr. Damlola online today. Today we'll be having chemistry, and under this chemistry we'll be learning oxidation number. How do I write oxidation number? How do I find this oxidation number? To get oxidation number very easily, I will start by teaching you some basic rules that guide you in writing or calculating the oxidation number of elements in compounds or elements in singleton. Elements in a free state. So let us begin. I believe that you've gotten your writing material as we get started. So now we begin. Chemistry, calculation of oxidation number. So let us begin with the first rule. Now the first rule, rule number 1, states that free elements, that is, elements in an uncombined state, has 0 as an oxidation number. For instance, e.g., let's say I have hydrogen. Here, the oxidation number of hydrogen, because it's just hydrogen, is not combined with any other element, is 0. Another example, let's say oxygen. Here, the oxidation number of oxygen here is 0. So that tells that any element in an uncombined state, that is not combined with any other element in a free state, we say that the oxidation number of such element is 0. So let's take rule number 2. Monoatomic ions. What do we mean by ions? Ions are elements that have charges. They have what? Charge. What do I mean by charges? Have you seen an element written in its symbol and being written with maybe plus or minus? For instance, okay, let me put that down. Monoatomic ion. E.g., have you seen chlorine written in this manner? This is a monoatomic ion. Remember that I said if we have an element in a free state, the oxidation number is 0. But rule number 2 is telling us that when such element, or let's say we have an atom of an element in an ionic state. What I mean by ionic state is carrying a charge, whether positive or negative charge. Then we will say that the oxidation number of such atomic ion is the charge on it. For instance, this chlorine, now if I ask you, what is the oxidation number of chlorine here? This chlorine, now the oxidation number is -1. Are we there? If I have something like this, sodium plus, this is +1, right? Let's say we have calcium, yes, calcium 2 plus. So this is what? This is 2. So the oxidation number of monoatomic ions are the charge on the ions. So you should be able to differentiate between an element in a free state, in an uncombined state, and monoatomic ions, right? Now let's take number 3. Number 3, we're talking about hydrogen. What is the oxidation number of hydrogen? Now, the oxidation number of hydrogen is always +1, except there is an exception somewhere, except in metallic hydride, that it is -1. Do we get it now? Now let us see examples of both cases. Hydrogen, let's say in H2O. When we look at H2O, so we should be able to tell that the oxidation number of hydrogen is 2, because the oxidation number of all the elements in a particular compound, or let me say in a neutral compound, I was still going to mention this, is equal to 0. So this is equal to 0. So if this should be equal to 0, meaning that if the oxidation number of oxygen is -2, that is, everything that we have for hydrogen should be +2, right? So that we can have +2 minus 2 equals to 0. And we have 2 atoms of what? Hydrogen here. That means +1 multiplied by 2. So -2 is equals to 0. So that tells that the oxidation number of hydrogen here is +1. So for any compound at all, the oxidation number of hydrogen is always +1, except in metallic hydride. You know what we mean by metallic hydride? No, we have on the periodic table group 1 to be alkali metals and group 2 to be alkali earth metals. So any member of this group 1 1 and group 2, when they react with hydrogen, we have metallic hydride, right? So in that case, the oxidation number of hydrogen is always -1. Let's see the case of sodium hydride. Sodium hydride. So look at sodium hydride now. The oxidation number of sodium is +1. How do I know that? I was still going to tell you that later in this video. So the oxidation number of sodium is +1. Then how do I get for hydrogen? Then hydrogen must be able to complement +1. So it should be -1 so that I can have 0. You know that the oxidation number, or let me say the sum of the oxidation numbers of elements in a neutral compound is 0. Should I come again? The sum of the oxidation numbers of the elements in a neutral compound. I will differentiate what I mean by neutral compound, and I will tell you the opposite of neutral compound. Now, in a neutral compound is a compound that do not have a charge. A compound in which there are 2 or more elements, and at the top of the should I say molecular formula of the compound, there is no charge. So it is neutral. It is not positively charged or negatively charged. So it is neutral. Therefore, the sum of the oxidation number of the elements in that compound is equal to 0. Therefore, if sodium here is +1, I will tell that hydrogen is -1. So this is the case for all metallic hydride. Whenever we have a metallic hydride, probably calcium hydride, we should always know that we are going to have -1. Is that clear? So the oxidation number of hydrogen is always +1, except in metallic hydride that it is -1. Now let's continue. Rule number 4. Oxygen. Let's talk about oxygen. Now the oxidation number of oxygen is always -2. The oxidation number of oxygen is always -2. However, there is an exception too. Except in hydrogen peroxide, that the oxidation number of oxygen is not -2, but what? It is -1. Let's check it out. You know, we've said hydrogen is +1, except in metallic hydride. And looking at this, it is not an hydride, Abi. It is not a metallic hydride. So oxygen is not a metal. So we know that it is just a neutral compound. Therefore, we know that hydrogen is +1. Now, +1 multiplied by the number of atoms, that's 2. So plus, let's say we don't know, for oxygen, x multiplied by 2, that is 2x, equal to 0. So I should have 2 times 1, 2, -2. So we divide both sides by -2. So I should have x to be equal to -1. So meaning that in hydrogen peroxide, the oxidation number of oxygen is -1. So take note of that. Oxidation number of oxygen is always -2. However, in hydrogen peroxide, it is -1. I believe that is clear. So let's continue learning these rules. We need to learn all these basic rules so that we can be able to deal with complex calculations of oxidation number. Now, another example I want to give you now is that fluorine is always -1. Whatever the case is, fluorine is always what? Fluorine is always -1. The oxidation number of fluorine is always -1. Now let's take number 6.
Follow Jumdam Academy and stay tuned for the next part. Like, comment, and share for more videos like this.